Hi guys, so in the last video we did the concepts of complementary genes. Today we will be looking at the Punnett square of it, right? So let's quickly recap. Complementary genes are genes in which two would give you a particular phenotype, right? Two genes present in a dominant state would give you a particular phenotype. So for this, let's start with the cross. So obviously we will take total homozygous for both the dominant and the recessive characters. Now because there are two genes involved, we have taken this for the purple flower here because both the capitals are there. So both P and C genes are in dominant. We have a purple flower, and here we have taken a double homozygous recessive for the white flower, which is where both the C gene and the P gene are present in their recessive states, correct? So that's our parent. When we will cross it in our F1, we'll obviously get a perfect heterozygous condition in which we have one copy of capital C and capital P, that is dominant C and dominant P, which makes this a purple flower, right? So now let's come to the cross. If we look at the gametes that this can produce, then obviously there are four possible combinations: capital C, capital P, capital C, small c, capital P, and small c, small p. So these are your four combinations, correct? When we cross them, this is the dihybrid cross that comes out. When we look at this cross, let's see how many of whites and purples we eventually end up getting. So for any combination in which we see a capital C and a capital P together, we know it's a purple flower. So this is a purple flower. 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 Correct? Coming down to this again. Purple. Now this is white because we don't have the dominant copy for P. So this is white. This is again a purple flower. This is again white. This is again purple, purple. Again here we have the dominance for P, but we don't have the dominant for C. So then it becomes white. This again has no dominant in the first copy. In the second there is. So this is again white. This is again purple, white, white, and this is obviously the double recessive condition, which is again white, correct? Let's count. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 copies of purple, and we have obviously then 7 copies of white, correct? So our phenotypic ratio for this particular cross then becomes 9:7. For this, you get questions on the species, which again, to recap, is Lathyrus odoratus, commonly known as the sweet pea, in which it was worked on, and the ratio is 9:7, and obviously the combination is when both of them are present in their capital or dominant conditions. I hope the cross was clear. Thank you.